Hi, this is Mr. Alexander, and I'm going to talk to you about inverse normal calculations today, which is part 2 of the normal distribution, IB Subtopic 4.1. I'm looking at number 2 here. The mass of coffee grounds in its super strength coffee bags is normally distributed with a mean of 5 grams and a standard deviation of 0.1 grams. It is known that 25% of the coffee bags weigh less than p grams. Find the value of p. I always start by drawing a normal distribution. And I mark the mean of 5, and I put the standard deviation of 0.1. And it's known that 25% of the coffee bags weigh less than p grams. 25% is going to be like right there, and less than is shaded to the left. So if I want to know that value of p, I'm going to use the inverse normal function in the calculator. And the probability below that value of p, they said, is 25%, which is 0.25. So I'm going to type in 0.25, the mean of 5, and a standard deviation of 0.1. To get that in the calculator, it's second vars 3. I'm just going to type it in, 0.25, 5, and 0.1. And that gives me 4.93. So that value of p equals 4.93. Now the units are important here. It's not a probability now, so there's going to be units. So this is grams. Same thing in number 3. The heights of Dutchmen are normally distributed with a mean of 181 centimeters and a standard deviation of 5 centimeters. It's known that 35% of Dutchmen have a height less than h. Find the value of h. I always start with a picture. And I put the mean of 5. The standard deviation, the mean was 181. And the standard deviation is 5 centimeters. And I want to know 35% of Dutchmen have a height less than h. 35% is going to be like right there. There's h, and shade the area we know. That's 35%, or 0.35. So in the calculator, I'm going to do inverse normal of 0.35, 181, and 5 for the standard deviation. So that value of h for height, second vars 3, 0.35, 181, and 5. That's going to be 179 to 3 significant figures, and the units on that is centimeters. Now, one thing we haven't talked about that's actually really important is the calculator only knows the area to the left, never the area to the right. It's going to be important here. So the weight of these fruits is normally distributed with a mean of 20 grams and a standard deviation of 0.8. So I've got a mean 20, standard deviation of 0.8. It's known that 15% of the kumquats weigh more than k grams. So here's k, more than is to the right, and that's 0.15. But the calculator's not going to help us if we're going to the right. It's only going to help us if we're going to the left. So what I really want is the probability that's over here. And that's going to be 1 minus 0.15. Which is 0.85. So I'm going to do the inverse normal of 0.85, 20, and 0.8. So I'm going to type that in. 0.85, 20, 0.8. The value of k to 3 significant figures is 20.8 grams. Like that. That's the basic idea. Let's do some of these IB questions that are on the back here that are a little bit tougher with the time that we have left. So this was on the IB exam. Can't remember if it was last year or 2 years ago. But it says the weight W of bags of rice follows a normal distribution with a mean of 1,000, standard deviation of 4. Find the probability that a bag chosen at random weighs between 990 and 104. So since it's asking me for probability, I'm going to use normal CDF. And the lower bound is 990. Upper bound is 1004. The mean is 1000. Standard deviation is 4. So that's going to give me the probability that's between those two. So that's second vars 2. 990, 1004, 1000 for the mean, standard deviation of 4. And we've got 0.835. 95% of the bags weigh less than k grams. Find the value of k. So again, I always draw a picture. There's my 1000. And 95% is going to be like right there. And now we'll call that k. Weighs less, that's all this business here. So if we're trying to find the value of k, we're going to use inverse normal. And we're going to say 0.95 for 95%. The mean of 1000, standard deviation of 4. And we'll see what it spits out here. 0.95, 1000, and 4. And that's going to be 1006.579415. Now if you're going to round that, 3 significant figures here is 1010. Because that's going to round up to 1010. So be careful with the rounding. A bag of rice chosen at random, or a bag chosen at random, 1000 minus A is less than W, greater than 1000 plus A equals 0.9. Find the value of A. So this one's kind of tricky. Draw a picture though. This is probably the hardest question on the whole assignment. So you got your 1000 here. And then over here, you've got 1000 minus A. Over here, you've got 1000 plus A. And in the middle there is 90% of the data. So the question is, what's going on in the tails here? If the 90% in the middle, that must mean there's 5% here and 5% here. Right? So I'm just going to rewrite this statement here. I'm going to keep the W. I'm going to keep the 0.9. Well, I'm going to figure out what these two values are by using the inverse normal calculation here. So let's do the one on the left first. Distribution, inverse normal. Now looking at my picture, this one is 5% up below, so I'm going to put 0.5. Keep the 1000, keep the 4. That value right there is 993.42 whatever. Right? And this one over here is going to have 95% of the data below, so if I change it to 0.95, well, that's the one I've already done. That's your 10,000, or 1006, right? 1006.579. Let's just do this to 3 significant figures to keep this simple. That makes this 990. That makes this 1010. So the value of A is going to be 1000 minus 10 and 1000 plus 10. A equals 10. Now, if you didn't round it, then you might put A is 6.579. It just depends on how you answered it. So it's either A equals 10 or A equals 6.579, like that. I've got time to do this last one, and then we'll be done. Factory makes metal bars. Hold on. A factory makes metal bars. Their lengths are assumed to be normally distributed with a mean of 180, standard deviation of 5. Following diagram shade the region representing the probability that a metal bar chosen at random has a length less than 175. Well, if that's 180 and a standard deviation of 5, 175 is 1 standard deviation away. And length less than that is all this stuff over here. Okay? Find the probability the length of metal bar is less than 175 the probability that a length of metal bar is less than 175 is equal to the probability that the length is greater than h. Write down the value of h, so that h is going to be over here. If that's one standard deviation in that direction, that's one standard deviation in this direction. So minus 5 plus 5, 185 equals h. Find the probability that the length of the metal bar is greater than one standard deviation of the mean. So I want the probability that h, or the length, I guess, is greater than 185. That's just stat calc 2. Or sorry, second vars 2. Wow. 185, 199. The mean is 180. Standard deviation is 5. And it's going to be approximately 0.159, which is 15.9%. Alright, that's all I've got for you today. Thanks for watching standard deviation, standard normal curve. We'll see you next time.